Okay, good morning. First of all, yun nga, say sorry that for forgetting to set this meeting as early as last night. Okay. Because I really did forgot to set this meeting. After my 9 p.m. class last night, I went to sleep diretso. Okay. Then it was early this morning when I woke up that I remembered that I have to set a meeting for today. Okay. So actually ang first na bala ko is to set the meeting at around mga 8 kasi gising na ako sa ng 3 eh. So gusto ko sana dire-diretso na ako magkaklase. 8 to 10, then after 10, tsaka na lang ulit ako matutulog. Ganun sana yung una kong balak. But upon realizing that I was not able to set the meeting, okay, yesterday. So, yun, 9 tayo nag-ano. 9 na tayo nag-start. Okay. So, first thing, I would like to ask muna, where are you on your activities? Hindi ko pa nababrowse yung eh. Hindi ko pa nababrowse yung reports nyo as of now. Okay, hindi ko pa siya nababrowse. Nabrowse ko siya siguro nung nakarang araw pa. And I'm seeing very few developments pa rin. Okay. Although merong konting progression. Okay. Just a reminder na mamaya yung soft deadline nung activities niyo. So I will do a preliminary check of your work later tonight after the soft deadline lapses. Okay. And baka makakita na kayo ng mga panakanakang feedback. Okay, wait lang saglit lang Okay. So, going back. Okay, sorry. May nangungulit eh. Okay, so going back. Again, as I was saying, I am seeing parang konti pang developments with your activity report. And at the same time, I'm also receiving very few questions. So that makes me think, that sends me that parang makes me think kung okay ba kayo sa ginagawa niyo o hindi. Kasi if you're having difficulty, I was expecting that you would be asking questions kung nagkakaroon kayo ng difficulty. But the fact that no one, or I am receiving very few questions from you, makes me think naman na okay na kayo. So which is which? Can I ask the class? Anyone?
Sir, di po namin alam paano mag-input, sir.
O kaya nga kaya nga di ba dapat sana tatanong niyo ako. I mean, I can answer naman your questions. Anong specific na hindi niyo alam kung paano i-input?
Kaya po namin, sir, mag-solve po ng mga problem, sir. Kaso hindi po namin alam paano i-input sa MATLAB po.
Pero nagagawa niyo yung procedure?
Hindi po, sir. Hindi po kasi namin alam paano i-input. Kasi ngayon lang po kami nakapaghawak ng MATLAB po.
Pero di ba your activity contains, for example, halimbawa to, let's go to activity 2. There is this di ba? Ito nagawa nyo to. Itong mga parts na to.
Doon kami sir na-stuck po sa activity 1 sir.
Activity 1. Okay. Ano ba activity 1? Writing scripts. Saan kayo nahihirapan dyan?
Sa pag-input po sir ng mga details po.
Like, anong in particular part? Anong kailangan i-input?
Kasi sir, tinry po namin i-input sir, tapos wala po lumalabas na sir, na outcome po dun sa in-input namin na.
Ano yung problem na tinatry nyo i-solve? That is what I'm asking first.
Yung question 1 pa lang po sir.
Question 1.
Apo.
Sabi dito for A equals 50,000, R equals 5% per year, and P equals 1,000, compute and plot B versus N and deduce after how many months will the loan be paid. Okay? Ito kasi yun. This question 1, okay, kung babasahin nyo mabuti itong if you would be reading this procedure, especially itong number 4, okay, that actually, itong mismong script na to, this code would actually answer this first part. So, ito ba nakuha nyo to?
Opo sir, kaso po pag mag-change ng parameter sir, di na po namin alam paano gagawin sir.
Palitan nyo daw yung A. So, nasaan yung A dito? Ayan, di ba?
Sir, idudugtong lang sa ilalim sir.
No, papalitan nyo talaga to. You set it as A equals, 100,000? You set it as A equals 100,000. You haven't tried that,
Di ba po, sir?
Yun lang. So, ayun, my point was sana na itanong niyo siya sa akin earlier on. Kasi nagkakaproblema pala kayo eh. You were having problems in those parts. So dapat na-address natin siya maaga pa lang. Kung nahihirapan kayo mag-inputs. Kung nahihirapan kayo mag-input doon sa part na yun. 'Di ba? So ano nangyari? Hindi na-stuck kayo. Na-stuck kayo doon sa question. O yun. O sayang yung oras ngayon. Na-stuck kayo doon sa part na yun. Eh, kung tinanong niyo ako, di sana natulungan ko kayo. Di ba? Sabi ko naman sa inyo, if you have questions, ito nga, ni-repost pa nga yun ni Mr. Sino nag-repost nun? Yung message ko sa inyo before, that
sir, ako yun, napindot ko lang po, sir.
Hindi, okay lang. Pero actually, magandang reminder yun na dito sa pinag-uusapan natin. Pero wala nang problema kung napindot mo. Naalala ko lang. Kasi I was wondering bakit kaya. Pero naisip ko bakit napindot mo nga lang. So, okay lang naman yan. Pero ito yung ito yung reminder na yun. Magandang reminder to eh. That you can ask questions. That is, yun naman yung sinasabi ko sa inyo pa before eh. That I would like this to be a more of a coaching session, not really a mass discussion. I would like it better if you would ask questions. If you have questions or inquiries, send nyo na sa akin. Yun lang naman yung hinihingi, yun lang naman yung parang inaano ko before pa. Okay? Meron ako nakakausap sa klase ninyo, panaka-naka, siguro mga 1 or 2 sa inyong class that I was able to talk to this past few weeks regarding the activities. Okay? In which even if you ask them, I was answering questions naman. I'm entertaining questions naman. Hindi naman ako although syempre some of the questions that I pose would actually be those questions that would also really make you think. So kumbaga hindi ko naman sasagutin directly yung questions nyo as it is, but I can actually make it parang a learning experience for both of us. Okay? Pero yun nga lang, the problem is nahihirapan pala tayo mag-input. Nahirapan tayo mag-input but we were not able to address that. Eh paano 'yan? Mamaya deadline na. Paano 'yun? Nasaan ba 'to? Later on your activities would actually activity 0 up to 3 would actually have its deadline later on. At midnight. So how do we catch up now? Nasaan yan? 1. Let's call this procedure 1. Okay, let's try to run this one. Let's try to execute this one. In my keyboard, I'll just press F5, but you can actually press this one if you want to know. Okay. So we are expecting that the output of this is a graph because of the final command. Okay, because of this command, the output of this is a command. Is a plot. Okay, it's a stem plot. We call it stem plot. So if you are to recall your activity 0, okay? The graphing tools or the graphics tools in MATLAB were covered. Okay, so you might be you can recall from that activity that stem is one of those graphing tools. So that is why when you do that, you will have this you would have this kind of plot or kind of graph. The question is, question 1 asks, how do you now solve that problem? The question there was deduce after how many months will the loan be paid? So using this plot, how do you deduce? How do we deduce? How do we know? Here, what does B represents here? What quantity does B represent in this formula? Anyone? Ano yung represent ng B? Sabi niya, B represent what is left of a loan at month end. So B represents what is left of a loan after a certain number of months. And if you are what you have loaned is this amount, okay, and then you are paying P monthly payments. Okay, given that the interest rate is 5% or the annual interest rate is 5%. So again, B represents what is left of the loan after a certain number of months. So the question here for number 1 is for you to deduce how many months will the loan be paid. How do we get that answer, or how do we get that that deduction of that that number of months in this graph?
Kapag equal to 0 na, sir.
Yung alin? Which one?
Yung B po.
So, what do this graph represent ba?
Kung ilan na po yung
I mean, what does what quantity does the x-axis represent? What quantity does the y-axis represent?
yung X po is yung number of months.
Okay, so x-axis represents the number of months, while
Yung Y-axis po yung amount po nung loan.
so y-axis represent the amount of loan left after 10 months.
Yes,
So for
sir.
example, if you have to take a look at this particular data point here, okay, at month 0, okay, at month 0 the month is X, okay, and the amount left is Y. So at month 0, it means that you have 50,000 ano ba to, pesos?
50,000 na, sir.
Oh, wala binigay na unit. There's no unit given. So let's just assume that it's pesos. Okay. So it is 50,000 pesos, for example. Okay, you borrowed 50,000 pesos at month 0. Okay, after 1 month, well, your loan has already gained an interest. Okay, and after you paid 1,000 in order for you to meet your obligation of 1,000 monthly payments, your loan now becomes 49,208.30. Diba?
Yes, sir. Apo.
So how do we can deduce now the number of months by which we can pay that amount of loan amount, okay? If that amount, okay, becomes 0. So we find now at what month will that value become 0. Now there's no particular value there that it becomes 0, but this is the point after 56 and 57 months, okay, after 56 and 57 months, that your V, or the amount that remains in your loan crosses the 0 axis, the 0 threshold, because that's 183 pesos after the 56 month, and then after that it becomes negative. So in that case, you don't have you already have paid the loan already,
Yes, sir.
right? So how many months can we pay that loan?
Mukhang hindi na tayo makakalabas
March
nun.
57, sir.
So we will be able to pay the loan after 57 months. Di ba?
Yes, sir.
Now, the question now then is that you try now to change A to 100,000, your interest rate to 3%, okay, and your P now to 8,000. That means now your problem is asking, what if you loaned 100,000, okay, and that loan has a 3% per year interest, okay, and then you are paying 88,000 per month. So you simply change those parameters. Let's change A, for example, to 100,000. Let's change R to 3%. Okay, and let's change P to 8,000. And then let's execute the program again. There. So check natin ha. Again, using the data cursor here, okay? You can check that at the start you have 100,000 pesos loan. And then you count how many months will that become negative. So a little over a year, you are paid now already on your loan.
Yes, sir.
Ayan, that's how that's how this problem should be solved. Any concerns about that?
Wala naman po, sir.
How about the others?
None, sir.
None po. Okay. So, that is what I was asking of you naman. If you are having difficulties, ask me. Yun lang naman eh. Okay? So again, I'll try to leave this to you. Because I would want to try to discuss activity 3. Okay, because activity 3 now is actually concerns actually your activity 3 would be where control systems would actually be starting to be considered. Activities 0, 1, and 2 are all introductory activities. We should have been finished long before. Masyado na nga tayong late sa natin eh. We are really late on our calendar. We are already on week 8. Okay? We are already in week 8. We should have been on activity 7 at least or activity 6. Dapat nasa ganun na tayo. Okay? But what happened then kasi is this will be verified by your classmates in the that are attending the lecture class. That we are also behind our lecture class because we are just beginning to discuss time response. So sakto lang. I mean ayun, talagang late talaga. Okay. So anyway, so can I entrust this to you now? This activity. And again, if you will have questions, please do ask me, okay? Hindi naman ako nakangagat.
Tulad pa lang yun.
Wait lang. Okay. So, there's your activity 1. And again, I would like, especially those that just log in, I would remind you that today or later today is the ayan. Is the soft due date of the submission of your activities from weeks 1 up to last week. So which actually covers activities 0 up to 3. Okay? And if you take a look at the calendar, after 2 weeks would be its hard deadline. Okay? But here's the thing. After this activity 3, I would be assigning activities 4 and 5. Kasi 2 weeks to eh. So I'll be assigning activities 4 and 5. So if you are not yet done with, for example, activities 0, 1, and 2, okay? And then say, for example, you'd be using this soft deadline to not submit. Okay, just remember that you would be working, you would be pressed. Okay, you would be pressed to work on these activities 0, 1 to 3 until February 20 only. Okay, and then 2 weeks after that, you would have your other activities. So if you're left behind, okay, already, okay, please try to do some catching up. Especially this is the thing that that I was really concerned with. When I look back, Okay, when I look back with our meetings, with our online sessions, we only had 3. This is just our 3rd online session, if I can remember, if my record is correct. This is our only 3rd online session. Okay? We should have given you more time to work on these activities. You should have more time in working on this because you had more free time because I was not meeting you. Okay? You should have more time to read the activities and know if there are problems that you are encountering and ask questions from me. You have that privilege of time. Unlike my other section kasi, my other class in laboratory, we have met already around parang 5 weeks na. We have already had 5 synchronous sessions starting from the start of this term. So they actually had less time because they had to attend the online session. So if they are attending the online session, they had less time. But here's a surprising thing about that. I am seeing more development on their end. I am seeing that their reports are progressing at a faster pace compared to your class. So they are attending the online session and then they're trying to work on their activities. Tapos tayo, we don't have online sessions. And then we are also not working on our activities. So parang that's not good. Okay? So I hope you can try to do some catching up. Okay? Again, it's not really the amount of online sessions that we had Okay? The activities are there. I am always available for you to ask me if you have problems. I have asked you before if you have already access with MATLAB. You said yes. I asked before if you have computers, if you have laptops, or if you have PCs. Okay, you said yes. So we were okay na. Okay, all we need to do is just work on the activities. Okay. Do I make myself clear now?
Yes, sir.
Now let's discuss this activity 3. Okay. So system modeling, no? In control systems engineering, okay. When we talk about control systems engineering, we are involved in the design. We are involved in designing systems. Okay. In which case, one part of the design is to actually come up with what we call a system model. Okay. We don't really jump into the design process by having all of your components right there. Okay. You might be used to having a design, okay, or trying to do a design that is based on, for example, a system that you have found in the internet, okay, and then try to implement it on your own without really much thinking. Para saan ba yung for what these components are, for what this you don't really have this good sense of how the system would actually work. Okay? And if the system that you or if your project, okay, if your project works, okay, it means from the design of the internet, from the design you got from internet, you bought the components, you build the system, and then fortunately your project works. And that's fine, okay? But chances are there will be something wrong with what you have done. Okay? there is something the process that you have used in order for you to come up with a design is not really the correct way. Okay, not the correct engineering way of doing things. Okay, because when engineers do their thing, okay, when engineers do their design, they actually start with models. Okay, they actually start with models. In the case of, for example, electrical networks, they would come up first with the schematic. Same thing with mechanical with mechanical systems. They would actually come up with they would first come up with a schematic. Okay. I'm not really familiar with how the schematics in the mechanical engineering design is presented. Pero from what I know, you also use schematics in order for you to present designs. Tama ba? Is that true? That you also use schematics?
Parang diagrams lang, sir.
Yeah. Yeah, diagrams, schematics.
Parang schematics, sir, pero hindi parang katulad ng sa atin.
So, that is what I was thinking, no? I was thinking that you still have your schematics, okay? And this schematics actually come from an extensive analysis standpoint. So, when we design system, we first come up with the system model before we actually do the design. Because what we want to do is we want to have your design meeting a certain requirements. Yun naman yun eh. That's the essence of designing systems. Your system should meet certain requirements. Okay? It should meet certain requirements. So, for you to be sure, okay, that it meets certain requirements, okay, you need to analyze system models first that corresponds to your design. Okay? So, what would happen is if you're just trying to emulate a certain design, and then whoever gave you the design problem has specific requirements, okay, has this specific set of requirements, but you found out, okay, after building the system, after building the physical system, that your system does not meet the requirement. The question is, how do you adjust? Okay, how would you adjust now your system in order to come up with a system that meets those requirements? And if you don't know how the system was designed in the first place, then chances are you'd be having difficulty meeting these requirements. That's the drawback there. That's a drawback of coming up with a project that is not really your design. Okay. And now in the advent of what do you call this? In the advent of the advancement in computing, okay, in computing technology, we are now able to have this system, okay, this system model is now essentially, aside from being a schematic, okay, this system model is now essentially a computer-based model. It's now essentially a computer-based model. Okay. And this computer-based model, okay, because we don't, the only way that we can actually communicate things with our computer is by numbers. Okay. So these computer-based models essentially are mathematical models. Okay. They are essentially mathematical models. So in our case, since we are using our computers in order to come up with a design, the first step in engineering systems, okay, not just in control systems engineering, but in all engineering systems, in all aspects of systems engineering, okay, is to actually come up with a computer-based model, okay, that is based on mathematics. So these mathematical models may be equations, okay, they may be equations, they may be algorithm, they may be procedure, okay, they may be in terms of a what we call flow chart, okay, and many more. So maraming pwedeng there are many ways to to express your model, okay. But in our case, these mathematical models actually would come in what we call transfer function. In general, transfer function. And as you would be able to see later on in this activity, that transfer function is not really just the way to model your system. Okay? There are many ways. Okay? Actually, the first way to when you say control systems, okay? When you say control systems, we define control systems as sige nga, can you give me a definition of a control system of control systems? How you understand the term control systems? Anyone? Anyone? How do you understand? Hindi naman kailangan formal definition. Just how you understand control systems.
Siya sir yung nagmamanage tsaka nagko-command sir.
Manage and command.
Sir yung system, siya po, using control loops.
Okay. Command systems using control loops. Control loops. Okay. So, sige, that's one. Okay. Ano ba? Anyone? Then we'll take keywords out of this para mabuo natin yung so that we can come up with a with our with a definition of control systems that really fits our understanding. Okay. Actually dito I can highlight itong command.
Ano sir? Manually or automatically controlled through feedback.
So it can be manually controlled. Okay. Or it can be automatically controlled.
Yes sir.
But with the use of feedback loops.
Yes sir.
Sige, ano pa? Any more idea about control systems?
Meron pong sir, system error detection.
Which sige, there is this system error detection. Sige pa. At this point, Mr. Pangatungan is trying now to enumerate mga features. Okay? Mga known features of a control system. Sige, ano pa?
Sir, modify the behavior of the system.
Modify
The behavior of a system.
Pero basically this covers parang purpose ba niya? Does this yung sinasabi mong modify the behavior, does this cover yung purpose of your system?
Opo,
It means
sir.
every control system has this ability or has this objective of modifying the behavior. Ganun ba?
Yes po.
Okay, so sige. Any more ano? Any more idea? Sasama ko na dito sa system error detection kasi baka hindi nyo mabanggit. Disturbance, rejection. Yan. Baka hindi nyo kasi mabanggit. So ako na magdadagdag. That's ayan, may ambag ako. I have this I have my own contribution to the definition. Okay. So okay. Okay. Number one, control systems are systems that are commanded. Okay? They actually when with this definition kasi what Mr. Bullena, si Mr. Beata nagbigay nito. What Mr. Bullena was referring to here was a subsystem, okay? A subsystem that actually controls another system. Okay? A main system. So this might describe a controller, for example, okay, that controls, okay, or that that controls a certain plant, okay, or a process. So this is this is your main component, okay, this is your main component, but there is something that controls this, okay. Did I get your definition right, Mr. Bolena, dito sa unang part na to?
Yes po, sir.
Okay. So there is this parang control. Okay, there is this parang controller, okay, that commands or that manages, okay. And its actual purpose, okay, its actual purpose is to actually modify the behavior of this, which is correct, okay? Because your plant or process may be behaving in a certain manner that it is behaving naturally without the use of a control. Okay, without the use of a control. For example, if you are let's say we are dealing with a system, okay, with a system that controls the level of a fluid, for example. Okay. So meron yang parang let's say this is a tank. Okay, this is a tank. Meron siyang inlet. This is an inlet. And then this is an outlet. Okay. Now, if you're just trying to put in the fluid here, okay, and then trying to take out fluid so that you can maintain, okay, a certain level, okay, in your tank, okay. There are factors that you have to consider here, okay, because if for example your inlet allows a certain rate of flow, okay, allows a certain rate of flow to your tank, and the outlet allows a certain flow outflow into out of your tank, okay, then these two would actually determine how fast your level would actually be changing, okay. These two quantities, the rate of inflow and the rate of outflow, would actually dictate how fast this level would rise, okay, and how fast your system or your tank can actually maintain that level, okay. But that's not all, okay. If we want to actually, for example, say slow down, okay, we want to slow down the rate by which the level of your water or the level of your fluid rises, okay, we may want to change, sorry, bulol. We may want to change this parameter and this parameter. We may want to change those, okay, and we can do that either manual, okay, using manual control, okay, but this course actually deals with automatic controls, with automatically controlling these parameters, okay, with automatically controlling these parameters, so that we can not really kumbaga, we would like to have less intervention, less human intervention when it comes to this kind of system, okay. Is that does that do those make sense? Do those points make sense?
Yes, sir.
So the point is, there is this system, okay, as Mr. Bolena was suggesting, there is this system that should be able to control this and this. Okay? There should be a system that should control this rate of inflow and rate of outflow. And what is that kind of system? They may be valve systems. Pwede nating, we can use valves here. How do we symbolize valves pa? Halimbawa, yan na lang. Let's have that as valve. Okay? And then we also have a valve here. Hindi ako familiar sa mga schematic symbols ng ilang mga components. Okay? So, let's say this is a valve. Okay? An inlet valve and an outlet valve. Okay? So, for you to be able to control the rate of inflow, you may press this down so that you may slow down the inflow, or you may speed it up by pulling it up. Okay? Same thing here. You can you can press it down so that you can close the valve so that you can control you can slow down the outflow or the rate of outflow of your liquid, or you can speed it up. Okay? So ito yung tinatawag ngayong this is what we call now controllers. Okay? In this kind of system, these are now called controllers. Okay? Is that clear?
Yes, sir.
Now, how do we make it now automatic? Okay, that's the question. Kasi what I would by the way, ito pala. Since nabanggit na rin tong modify the behavior. As you can see, there is this certain rate of let's just assign it as R. Okay, let's assign it as R. Okay. This R actually represents the rate of level change. How fast your level is changing. Okay? So that's R, for example. And that R is actually the difference between the inlet rate and the outlet rate. Yung R na yon, how fast this level is changing is actually the difference between the inlet and the outlet rates. Okay? If you actually change any of this, okay, using a certain system like a valve system, then that valve system acts as the controller. And its objective is to actually modify the behavior of your process. This is your process. Your process is a level control. So if your process is a level control, okay, the rate by which you can set, for example, how fast the level of the fluid inside that tank is flowing or is changing, okay? Ito, for you to be able to modify this one, you need to modify this too. And how do we modify this too? By using valves, which are your controller. Okay, is that clear?
Yes, sir.
Okay. But that's not all. Okay, that's not all. The thing is that since we want to make our system automatic. Okay, since we are dealing with automatic control systems. Okay? There should be a way for you to say that I have already reached, for example, the level that I needed to. Okay? If this system is something like tries to maintain a certain level of fluid inside its tank. Okay? It tries to maintain this level. Okay? There should be a way for us to know if that level has already been reached. Okay? There should be a way for you to do that. Okay? And for you to do that, you should be able to measure. Okay? If this plant or process is a level control process, okay? The output here is the level of the fluid inside the tank. And there should be a way for you to measure that level. Okay? So that you would report it, okay? You would report it to the controller that the level hasn't been reached. So that you need to keep on maintaining the valve to be open. Okay? And of course, you need to be able to determine what level it is. So you may want to say here, this is the desired level. Okay? That may be the desired level. Then you would want to measure the difference between the desired level and the actual level of the fluid in the tank. So you may want to measure the difference in that. Because the higher the difference, the more you want your controller to open the valves. At least the inlet valve, and to close down the outlet valve. So that the level inside the tank would actually rise faster. And then if it is now close to that level, then your controller would be able to detect that, okay? Because the difference here is very small. So therefore, the controller now would try to lessen this inlet valve, or lessen the input from your inlet. Okay? Up until the time that it reaches the level that you desire, so the difference there now is 0. So now the level shuts off both the inlet and the outlet valves. Did you get the sense of the process?
Yes, sir. May,
Oh. Was that clear with you?
sir, meron pong detector.
Okay. So the important thing here is that there is this input or command, okay? There is this command that you have to consider, okay, which normally dictates what should be the desired output, okay? We call also this as reference. Okay, we call this as reference input, because that's the benchmark. Okay, we are setting the output to reach that part. Okay, so this is our reference input. Okay, while this would be your actual output, we can also call this as your controlled variable, because this is something that you are trying to control. You are trying to call, if you have a level control system, that means you are trying to control the level of a fluid, for example. If you have a speed control system, it means you're trying to control the speed. So therefore, the output here should be speed. Is that clear?
Yes po, sir.
If we have a position control system, then our control variable would be position, whether that's a linear position or a angular position. Okay? So there. So you need a command or an input, okay? And then you also have a control variable. Now, you need a controller for you to be able to modify the behavior. Okay? This is the behavior of the system. The system that we are trying to point out here is actually this plant. So this may be more correctly stated as modify the behavior of your process or of your plant. Okay? So a controller, okay, a controller would actually manage and command your process or your plant, okay, using loops, okay. And that loop, in this case, in this case, the purpose of your loop, this loop, is for actually to be a mechanism to measure the control variable and compare it with the reference, okay, so that we will be able to run your controller, okay, in a manner that it is controlling the behavior of this plant or process. Are those things clear with you?
Yes po, sir.
Okay. Now, the advantage of this kind of configuration, we collectively, this entire thing, is now what we call feedback control systems. We call this feedback control systems. Okay? O system, kasi isa lang naman siya. So, this is a feedback control system. Okay? It consists of, ito yung entire, this is the entire topology of that. It actually consists of an input transducer. Hindi kasya yung susulat ko. Let's have it as, we have an input transducer. Okay. We have here what we call a controller, as stated earlier. Then we have your process we have the process or plant. Okay. Then we have here what we call the output transducer. Okay. So here is the complete topology of that that diagram. So we have here the reference input. Okay. So basically the reference input is a signal, okay, dependent on time. So it's a signal that changes in time. Okay, while the output is what we call the controlled variable, which again is another signal that evolves in time. Okay? So here is the complete topology of your feedback control system. Although we have already defined what the controller is doing. We have already defined what is the plant doing or the process doing. Okay? We haven't named this one yet. Okay? Pero alam natin what would be the purpose of this. That is to do measurements. Okay? It should measure your control variable and compare it. It doesn't compare, it just measures. Because what compares your control control variable with that of the reference input is this. Okay? And in this block diagram, we call this entire thing the block diagram. Okay? We call this entire thing the block diagram. Okay? But this particular component here is what we call a summing junction. Okay? Which basically tries to compare. It tries to compare your control variable with that of your reference input. Okay. But what is this input transducer for? Okay. What is this input transducer for? This input transducer converts your input signal into a form that, number one, similar to the control variable. Okay? Because basically, hindi nyo naman yan ma-subtract. You cannot subtract this algebraically if this and this are different quantities. For example, if this is speed, angular speed, and this is angular position, you cannot subtract speed and position. Is that correct?
Yes, sir. Magkaibang po sir.
Because these two are different quantities, so we will not be able to subtract them. So what the input transducer would do is to actually convert, for example, this speed into position also. If that is required. Okay, o kaya para mas so that you can understand this, pwedeng ganito. Let's say we have a temperature control system. So if you have a temperature control system, okay, if you have a temperature control system, the output is controller, is temperature. Okay, the actual temperature. But the question is, how do you say to your system that I want a temperature of 26 degrees, for example? Hindi, mainit pala yun. Say for example, 20 degrees for your room. Say for example, this is an aircon. The entire system that we are considering is aircon. Okay? How do we say to our aircon, how do we communicate to our aircon that we want a 20 degrees room temperature?
Sa input, sir. reference.
Yeah. Yun nga, ipapasa natin siya sa input. Pero do we just instruct our how do we pass on the instruction to the aircon that we want a 20 degrees room temperature. So basically tatanong ko doon, anong input transducer ang pwede natin gamitin? What input transducer can we use for that purpose? So that this reference can actually be interpreted by your system correctly.
Yung switch knob po.
Ang tawag natin doon? What particular ano yung iniikot nyo sa aircon? What do you adjust on your aircon so that you can achieve a certain temperature?
Thermostat, sir.
Yun, sa thermostat. So you say to your thermostat, that you adjust your thermostat to do a 20 degrees Celsius temperature. Okay, so that the aircon now understands that you want a 20 degrees that you want a 20 degrees temperature. But actually that's not all. Okay, that's not all. Your thermostat is actually a knob. Basta naiikot siya. This is rotary eh. You rotate this so that you can set this temperature, a certain temperature to this into a certain value. Okay? So inside this is actually a potentiometer. Okay? In which that potentiometer is connected to a circuit, okay? Connected to for example, a voltage supply, okay? In which an angular position here, okay, an angular position in your thermostat corresponds to a certain voltage, okay? A certain voltage in your potentiometer, okay? And would correspond to a certain temperature. So sa atin, we understand this as just saying that we rotate, okay, we adjust our thermostat to set it to 20 degrees Celsius so that we can instruct our aircon to operate on to produce 20 degrees Celsius room temperature. But okay, there are some things that actually happens inside it. Okay, you get what I mean?
Yes, sir.
And here's the thing. Okay, here's the thing. So number one, similar to C of T. Okay. Number two, converse AT to a form that is one similar to C of T. Number two, that is accepted by your controller. Okay. That input transducer actually tries to convert RT into a signal that is processed by your controller. Because if your controller, for example, if your controller is electronic, as in the case of motor drivers, di ba we have motors, okay? Pero we don't really use motors by itself, okay? There is this thing that we connect to the motors we call drivers. And these drivers are electronic circuits. Okay? So if these are electronic circuits, what input does it accept?
Voltage.
So either it accepts voltage or current. Basta electrical quantity, it accepts any electrical quantity. So that's the role of your input transducer. That's the same thing here. For an aircon, for example, your controller, the one that controls your compressor, kasi the main component in an aircon would be the compressor. That adjust kasi yun yung nagpo-produce ng that component produces the temperature that we want. Okay? The compressor and the motor. Okay? So parang nangyayari is that the faster the motor rotates, the more air the compressor takes in, okay, and the colder the air it produces. Parang ganoon, okay? So that process or that those components, yung compressor at yung motor that corresponds to that is actually controlled by an electronic circuit. So if that is controlled by an electronic circuit, then this input transducer, for example, this thermostat, should be able to convert your temperature setting into voltage. into a corresponding voltage. Ganun din to, itong electronic output transducer ninyo. Since this is temperature, this is temperature. This measuring device, okay, which we can also call as a sensor, okay, should also be able to convert this temperature into corresponding voltage so that you can actually process it and be taken in by controller. Is that understood?
Yes, sir.
Okay. Now, so that's our control system. That's the entire picture of your control system. Oh, by the way, i-adapt natin siya dito sa level control. If this is process or plant, okay, if this is process or plant, and your controller is valve, the input to your valve is mechanical eh. The only way that you can adjust your valve openings is by mechanical means. It's either via a motor, okay, or via for example, mga relay switches, okay? You can actually use relay switches in order for you to control your valve. If you're using relay switches, okay, the input here is the desired level, so that's the command, okay? And that desired level should actually be converted into a certain voltage, okay? A certain voltage that corresponds to that level, okay? So your input transducer should be able to do that. So isip tayo ngayon, anong pwedeng what component can actually take in a level command and convert it to voltage and then control a valve. Okay? So kung relay switch yung yung option niyo, that might do. Kaya lang the problem with relay switches kasi is that they are switches. Ibig sabihin they just only take they just take in only two states. Either they are open or they are closed. So baka you won't be able to achieve the desired control kasi it's either you are just opening your valve or closing your valve. Okay? That's one thing, okay? Pero baka gusto niyo yung valve that is adjust using a screw that you can variably change the input the flow, okay? You can variably change the flow by adjusting how deep the screw is embedded. Okay? So pwedeng ganun. So that depends actually on how you perceive your system to be. Okay? And here's the thing. Normally, when you have a system, you actually start into this kind of diagram. Okay? You actually start sometimes use you can actually start designing systems by first coming up with what we call a functional block diagram, okay, and a schematic. The functional block diagram would actually show what are the components and how they are interconnected. Okay, how these components are interconnected. The schematic would actually show much more detail. Okay, but after you have this functional block diagram and schematic, you should be able to translate this into what we call mathematical model. Okay? And then from there, pagka nasa mathematical model na to, we have this mathematical model already. Okay? Wait lang Ikaw magulo. Yung aso ko. If you have a mathematical model already, then you can perform analysis. Okay? And then after that, you can now perform design tasks. Kasi again, as we have discussed earlier, that part of your analysis would actually be determining how your plant or your process initially behaves. Okay, and if the plant or process behaves in a certain manner that is not in compliance with the requirements that we had, okay, we may want to do design so that we can modify the behavior of your system so that we will be able to comply the requirements that we had. Is that are those points clear with you?
Yes, sir.
Wait lang ah.
Okay lang po, sir.
Gutom na yata yung aso ko. He's now disturbed. Okay. So, um, so that's the thing. That's our motivation of coming up with a mathematical model. Kasi even if we have this diagram and then we are not able to here's what happens kasi. After you have that diagram and that schematic, for example, it may be really costly if you went on buying the components needed and then building the circuit without actually knowing what would happen first. Diba? It would not be really practical for you to do that. Okay? You may want to do in the old times that we don't have computers. We may want to do some analysis tasks wherein given the system that we had here, for example, we have now your diagram. Okay, we now have your diagram. Using the equations that you were able to derive in each system, okay, you may be able to predict what will be the output or what will be the outcome of your design. Okay? But those are the thing when we don't have fast computers. Now that we have these fast computers, okay, we can actually translate this mathematical model into computer models. Okay. And then use modeling and simulation tools, okay, in order to come up with the analysis required. So instead of actually doing mathematical calculations, we can now use our computer to do the analysis for us. Okay? Kaya lang, okay, the thing is, before you actually instruct your computer to do analysis, okay, you need to supply the computer first with a computer model. Okay? That's the human part there. You may not be able to you may not be able to say to the computer that I want to have this kind of analysis for this system without actually telling the computer that this is the system that you have. So it is our task now to come up first with a mathematical model, okay, and then translate this into computer models, so that we can have our modeling and simulation software, such as in this case MATLAB, okay, to do the analysis for us. Via what? Via simulation. So is this kind of clear with you?
Yes, sir.
So broadly, that's how we view now your control systems engineering. Okay, that's how we in practice that's how we do engineering of control systems or the design of control systems. We before we actually build the system, we actually put it in computer models. Try to simulate them first, analyze what would happen to the system, do some corrections so that when we come up with a very good solid model as per our simulation, then that's the time we now build the actual system. But even then, after building the entire the system, even if you built that system using a very good and solid model, or use solid modeling and simulation processes in, for example, MATLAB, there is still this chance that you may have your model, you may have your actual system perform poorly. May ganong chance pa rin. Okay. Pero that should not discourage us from using modeling and simulation tools. Okay? That should actually the one that should encourage us kasi in spite of using there is this chance that the actual system is will behave poorly. What more kapag wala pa yung what more if we don't have this modeling and simulation? Okay, so the use of modeling computer-based models actually lowers down the cost of design tasks of system. So most of the engineering tasks that we have now would actually be should pass through what we call a modeling a modeling and simulation task. Okay? So that's our motivation here. May questions ba so far?
Wala naman, sir.
How about the others? May questions ba? Okay, so if none, I would like you to study this some of these tools here, like for example, how to solve this linear system of equations should have been taught with you. Kasi from what I understand, you also had your advanced math sa ME, right? I'm talking to ME people. You already had your advanced math.
Yes, sir.
Did you discuss linear
Yes.
algebra? Matrices. Did you discuss matrices?
Yeah po. Yes. Matrix.
Were you able to solve say 3 equations in 3 unknowns? Were you able to solve something like that in advanced math?
3 equations.
Kasi you might not be calling it linear algebra. You might be calling it matrices. Tapos you will be using it to solve equations. Or this is something that you haven't done yet. So baka hindi kayo sure. So okay lang 'yan. Ganda naman mga ECE. I mean
Di po ba sa new maths, sir?
Yes po. We talked this before.
you have tackled it before. Some of these topics are actually discussed in numerical methods, but they should I don't know if if all of us have numerical methods So there. Anyway, so in solving what happens kasi is that you may be wondering why do we need to discuss this this part, okay? Or why do we need to go through what we call linear system? Because when you are analyzing say for example, yung simplest examples of systems that we can have, which is electrical systems and mechanical systems. Okay. Some of them actually go when you derive equations or when you derive models, okay, for this kind of system, they actually boil down to multiple equations and multiple unknown systems. Okay, so it would boil down into that kind of equation. So that is why we would like to have a method in MATLAB in which we can solve this kind of systems. Okay, and there are two. Okay, and there are two. One is by the use of Cramer's rule. Okay, and the other is by the use of this equation. Okay, use of inverse matrix. Okay, but instead of actually implementing this, we would like to implement this na lang, which is what we call now the left division operator. Okay, and that part, yung how you do Cramer's rule. Okay, how you do Cramer's rule in MATLAB is demonstrated using this command or this set of commands. For example, for you to be able to solve this set of equations, does this problem now familiar with you?
Yes, sir.
How about the others? Is this problem familiar with you? The task here is to solve for the values of x, y, and z in order to be equal to this in order to be able to be equal to these values, 2, 31, and 13, given this set of equations. Is this now a familiar problem? Yan yung 3 equations, 3 unknowns na problem that we have. So, sige. Try to review na lang that part. I mean, this is something that is not really taught in control systems, but is taught in prerequisite courses for the control systems. That's the mindset that we should have. So, anyway, this should have been also done in algebra before. You should have been able to discuss this in algebra. But here, you would be able to solve this problem using this command, using this set of commands. Okay? But the more pressing task for us is to actually come up with, for example, a model for this electrical circuit. Okay? We would like to come up with a model for this electrical circuit. And let me just medyo malabo rin kasi yung nakalagay. So let me just redraw that circuit. No. Let's use black ink. That's 3S. And that's 1 over S. Class, wait lang Sandali lang Okay. I know the ECEs are do know how to do KVL. But for the ME people, do you know how to analyze this kind of circuits?
Yes, sir.
Okay, I'm asking the ME students. Because I might not be I might be having this impression that you have this This is where this is what I am really afraid of talaga. This part, okay, kasi your you might have different discussions on this kind of topics, or you may not yet be on this topic on some of your courses. So for the ME students, are we able to analyze this? Can you actually derive equations out of this?
Hindi po, sir.
There. Pero do you know Kirchhoff's law? Do you
Parang
know
familiar, sir.
Did you have Did you have courses on circuit analysis?
Sir? Electronics lang po, sir. Tsaka electrical lang po.
Oh yeah, yun nga.
Pero wala
Meron
po
kayong
yung
electrical.
Apo.
So you were able to discuss what is Kirchhoff's law, specifically KVL and KCL. Do these things ring a sound or ring a bell into you? No?
Hindi po masyado, sir.
Okay, so sige. That is now where the difficulty would be be encountered. Okay, so pero something like this, a circuit something like this, you know how to analyze something like this. Do you know how to come up with a what we call KVL equation out of this?
Hindi po, sir.
Okay. So here's the thing, whenever you have we will call this a loop. Okay, we will call this a loop. Okay. So in one loop, there would be a current flowing. Okay, there will be a current flowing there. Okay. Now, KVL or Kirchhoff's voltage law states that the sum of voltages around a loop is 0. So this is called a loop. Okay. If you add up the voltages in this loop, that would equal 0. Okay. Now, what you have to remember is that for every component, there is a corresponding voltage drop. So that means that if you have a circuit something like this, okay, if you have a circuit something like this, you would be able to measure a certain value of voltage if you use a voltmeter. Okay, if you use a voltmeter, you will be able to measure a certain value of voltage there. Now, let's call that voltage here, say VR1. Okay, and let's call the voltage here as VR2. The voltage here as VR3. Okay ba tayo doon? Is this clear? Again, we will try to measure a certain voltage on this resistors, across these resistors. So say for example, those voltages are VR1, VR2, and VR3 respectively. Okay? Is that clear?
Yes, sir.
Okay. Now here's what is going to happen. We can assume that this these voltages across the resistors are voltage drops. So meaning the voltage these voltages, okay, actually causes the voltage from the previous point here to drop. Okay? So which means that the voltage here is lower than the voltage here. Okay? So in that case, we will have to assign a negative in algebraically, we will have to make this voltage negative with respect to the voltage here. Okay? So that the KVL equation, kasi sabi nga natin, the sum of voltages around a loop is 0. That should mean that this voltage, okay, this voltage V of t, okay, and then this voltage, again, this is a voltage drop. So if you have something like if you have a voltage here, say there's a certain value of voltage here, okay, and then there's a value of certain voltage here. The value of voltage here is higher than here. So therefore, this actually causes for your voltage here to drop from this to this. So that actually subtracts. The voltage across R1 actually subtracts from the voltage here. Malinaw yan? Is that clear? Hindi. Ayun.
Yes, sir.
So sige. try to review your circuits ha, kasi kailangan natin siya dito eh. So the entire KVL equation here is this. VT minus VR1 minus VR2 minus VR3 equals 0. Okay? So that's the entire KVL voltage. We will call this as the KVL voltage. KVL equation, sorry. We will call this the KVL equation for this loop. Okay? But we take note that by Ohm's law, okay, by Ohm's law, do we know what Ohm's law is?
Yes po, sir.
Okay.
Yes po.
So Ohm's law states here that the voltage across a component equals the current flowing through it times its resistance. So that the voltage across R1 is the current flowing through R1. So we see this, if we assign a current flowing through this circuit as I, okay. So that is I of t, okay. So the current flowing here is I of t, and then we will have to multiply this by R1. Okay. And in the same manner, we have VR2 equals I of t times R2, and VR3 equals I of t times R of t, R3. So that our KVL equation now becomes V of t minus I of t times R1 minus I of t times R2 minus I of t times R3 equals 0. Or trying to rearrange this one, we will have V of t equals I of t. I have transposed everything here to this side. So we have I of t times R1 plus R2 plus R3. Is that Is that clear?
Yes po.
Okay. So now let's have two loops. Okay. This is a single loop kasi. So what if we have two loops now? Say for example, you have something like this one, this, R1, R2, R3, R4, R5, R6. Okay. Now we have two loops. Okay. Here we only have one loop. Now we have two loops. If you have two loops, you assign a current on each loop. So you assign one current here. Okay. One current here. Let's call it I1. Okay. And then another current here as I2. It's actually I1 of t and I2 of t. Okay. It's actually I1 of t and I2 of t. But I remove the of t notation for now so that you will not be confused. Okay. In fact, I can also do that with with V. So let's simply just refer to this as V. Okay. Is that clear? Okay. So since you have now two loops, okay, we now have separate equations for loop 1. Let's call this loop 1 and this as loop 2. So loop 1 and loop 2. Okay. So ganito. Okay, ganito. For loop 1, again, same thing. Sum of voltages in a loop equals 0. So same thing. You have V minus VR1, the voltage across R1, okay, minus VR2, okay, minus VR3, okay. But since there are two currents, okay, passing through R2, okay, this VR2, okay, this VR2 here would have two, what's this? This VR2 here would have two components. Okay, it would have two components. One component is the voltage produced by I1 on R2. And the other component is the voltage produced by I2 on R2. Is that clear? Wala na, suko na. Is that Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay. So it would have two components. So that when we try to do or when we try to compute this VR2, one part of it would be actually a voltage that is due to I1 and the other one is due to I2. Okay? Now, here's what we're going to do there. Again, this is equal to 0. Okay, that is equal to 0. Now, first of all, I would transpose this entire thing here, okay, to other side, and then equate it to V. So we will have something like VR1 plus VR2 plus VR3 equals V. Okay ba yan? Is this okay?
Yes po.
Yes, sir. Apo.
Okay. Now, again, VR1, okay, VR1 is the voltage across R1. So the current passing through it is I1. Okay? So we have VR1 as I times R1. Okay? Then plus. Again, your VR2 has two components. One component is due to I1 to. This is I1. Ayan. So, this is I1, R1. Okay? And then your VR2 has two components. One is due to I1. So that's I1, R2. That's the first component. And the other component is due to R2. I2. Okay. Again, bakit dalawa? Why is this? Why VR2 has two components? Because there are two currents passing through it. One is I1 here. Okay. I1 is passing here. And the other is I2. Okay. So that is why there are two components of the voltage that would be produced across R2. One is produced by I1 and the other is produced by I2. Okay? Now, here's the thing. If you take all currents or all voltages on this side, if you take all voltages due to I1 as positive, then this voltage due to I2 should be negative. Because current I1, this is current I1, okay, and current I2 are flowing in opposite direction. So if you measure your current here, okay, if you measure your voltage here, okay, as positive for I1, then the voltage for I2 should be negative. Okay, and vice versa. If you actually measure the voltage for I2 as positive, then the voltage for I1 should be negative. Is that clear?
Yes po, sir.
Yes po.
Okay. Now, this is I1 R1 plus I1 R2 minus I2 R2. And then VR3, okay, the voltage across here is what? That's I1, the current passing through R3 times R3, which is equal to V. Now, let me rearrange this, Let me rearrange this equation. Okay? I'll gather terms containing I1. I'll gather terms containing I1 all together. So I'll have, say, I1 times R1 plus R2 plus R3. Is that clear?
Yes, sir.
Oo, sir.
Okay. And then this is minus I2 R2 equals V. Okay? So this is the loop 1 equation. The KVL equation for loop 1. Okay? Loop 1 KVL equation. Okay? Ito yung kukunin na. This is what we will use later on. Okay, is that clear?
Yes, sir.
Do you have class after this? since who has a class after this, this 11 o'clock? Because our session is until 11 o'clock, right?
Opo, sir. Hanggang 11 na.
So, who has a class after, after 11? Sige. If you have a class after 11, it's okay to leave kasi this is recorded naman. Pero for those, I will continue on, I will continue on so that I can at least finish this part. Okay? At least finish how you can actually get equations from this. Okay? So that you can get equations out of this. Okay? Actually, these are the set of equations for this one. Okay? These are the equations for the set of equations for this one. So I would be showing how you will be able to get these equations galing dito from this circuit. And again, this is solved using MATLAB, using these codes. So therefore, all you need to learn from me, all you need to learn from me is how to get these equations. Okay? And then the steps here would actually show you how to solve them using MATLAB. Okay, is that clear?
Yes, sir.
Okay, and then I'll ask you, kasi it's probably that I would not be able to finish all of this. I would ask you to actually parang nabigay ko na to last week, pero I would ask you to watch another video which was the online session that we had for my other class in which I have discussed the second part of this activity. So, mamaya bigay ko sa inyo. Okay, so tapos natin to. Loop 2. What's the KVL equation for loop 2? Anyone? Ay, hindi, ako na pala para mabilis. So we start for example with this one. Okay? But again, if we are starting for example from here to here, okay, this would be a voltage drop. Okay? So we will assign it as a negative voltage. Okay? So we will have VR4 minus, again, this is a voltage drop. Okay? VR5, okay, minus VR6, okay, minus VR7. And then since there is no voltage source here, okay, because there is no VT here, there's no voltage source. So we will just have this as it is. All of them are voltage drops, okay? And then let's equate this to 0. Okay? And then simply multiplying this by negative 1, we will have VR4 minus, but 7? This is 2. Sorry. This is 4, 5, 6, and then 2. VR2. Okay. So VR4 plus VR5 plus VR6 plus VR2 equals 0. Okay? Now, again, this VR2 has 2 components. Still, this has 2 components. Okay? Again, why does it have 2 components? Because there are 2 currents flowing through R2. So there are 2 currents that produces VR2. Okay? So we now write the equation here as this way. Okay? We now write it this way. We will have VR4 is I2. The current passing through R4. So that's I2. Okay, so the voltage across here is I2 times R4. So this is I2 times R4. Okay? Plus, same manner, the current passing through R5 is I2. So the voltage across R5 is I2 R5. Okay? So I hope you're getting the grasp of this. Okay? As we go along. So I2 R4, I2 R5 plus VR6 is I2 R6. Okay. Plus, again, for VR2, there are 2 components. Okay. Now, since I2 is the current flowing in this loop, we will consider that current or that voltage due to I2 as positive. And so, therefore, if we consider the voltage across due to I2 as positive, then the voltage due to I1 is negative. So, we will have minus I2 R2 equals 0. I mean I1 pala to. That's not I2. That's I1. So I1 R2. Okay? And again, here's what I'm going to do. I would arrange this in a manner that I1 goes first and then I2. So we will have something like negative I1 R2 plus I2 times R4 plus R5 plus R6 equals 0. So this is now your loop 2 KVL. Okay? Is this clear?
Apo, sir.
Now, there is an easier way to do this. Okay? There's an easier way to do this. Just by looking at the circuit, you can be able to get these equations. Okay? Okay. Here's the technique. Here's the technique now. So again, it starts with you assigning I1 and I2 as currents for loop 1 and loop 2. Okay? Here's the procedure. Okay. So start with the current flowing in that loop, and then add all the resistances. Okay, that current is passing through. Okay. Again, start with the current on that loop. Okay. Start with the current on that loop, and then add all the resistances. Okay, on that that is passed through by that current. So the current passes through R1, R2, and R3. So we just have to add them. R1 plus R2 plus R3. Okay? So that's the first part of the Now, look for the component that is common to I1 and I2. And that component is R2. So what you do is you multiply that, or you subtract this with I2. Okay, and then multiply that with R2. Again, this is the resistance common to I1 and I2. Okay? This is the sum of resistances at I1. And this is the sum of resistances common to I1 and I2. Was that clear?
Yes, sir.
Okay, so then equate it to the voltage of the voltage source. Okay? That is connected to I1. Okay? So equate that to the voltage that is connected to I1. So that's V. So that is now your loop 1 equation. So if you can see this and then this, they are the same. Okay? It's just that here, I derive it using the conventional way. And here, we are using a certain technique. Okay? We are using a certain technique where we are just looking at the components. Okay? Is that clear? Okay. On the second loop, you do the same. Okay? You start with the current there. So that's I2. You add all the resistances connected to that I2. Okay, which is R1 plus R4 plus R5 plus R6 plus R2. Okay, and then you look for the common resistance between I1 and I2, assign it as negative, okay, and then multiply I1 times R2. Equate that to the voltage source here. But as you can see, there is no voltage source here. So therefore, this right side should be 0. Okay, and then let's just rearrange this equation. So we will write this as, we will write these equations as I1 times R1 plus R2 plus R3 minus I2 R2 equals V. And then negative I1 R2 plus I2 times R4 plus R5 plus R6 plus R2. equals 0. Why did I have to do that? I would want to have the same current in the same column. So if your arrangement is I1, I2, okay, in all of your equations, that should be I1 and I2 also. Okay, and this technique can actually be extended to 3 loops. Okay, if you have 3 loops, you can actually extend that idea. Okay, is this clear with everyone?
Yes, sir.
Okay. Now, for that part, we will now have to extend that idea. What if meron tayong there is now what we call inductors and capacitors, such as this one. Okay, we will now have inductors as capacitors and capacitors. Like this is an inductor. Okay, this is an inductor. Okay, this is a resistor. This is an inductor. This is a capacitor. This is a resistor. Okay? So how do we extend that idea? Again, same we will be able to get the equations, okay, using this same idea, very same idea. Okay? But how do we adjust it when your circuit now has capacitors and inductors? Okay. The basis for this is number 1, we will be using Laplace transforms. Okay? So we will be converting your circuit, okay, or we will be trying to make a circuit in what we call the S domain. So this is now an S domain circuit. But how do you do that? Okay, how do you do that? So to convert circuits to S domain using Laplace transform. Okay. Number 1, you have to convert Vt to V of S. Okay. And you have to convert I of t, okay, to I of S. That's number 1. So say for example, here, what happens here is that you have to assign currents here. So you may be assigning, say for example, this as I1, okay, of t. This is I2 of t, okay, and this is I3 of t. Okay, you would be assigning that. But instead of assigning I1 of t, I2 of t, and I3 of t, you assign here I1 of S. Okay, assign I2 of S and I3 of S here. Again, we convert I1 of t, I of t to I of S. And here, this is V of t. Okay, this should be V of t. I made it already V of S. So this first is sorry. This was V of t earlier. Okay, this was V of t. Now we make it V of S. Okay? Next. We will have impedances. We will have impedances. So you have 3 components. Resistor. Okay. You have resistor as components as resistor, inductor, and capacitor. Okay. This would be measured. Okay. This would be measured using the parameters R. These are variables, so they can take in numbers later on. Okay. So this can take numbers such as R. Okay. Inductor as L for inductance. Okay. And capacitor C for impedance. The units are, this is in ohms, this is in henries, and this is in farad. Okay? Now, we will have to convert this into impedances. Okay? So these are not impedances yet. Okay? We will have to convert that to impedances. Okay? So to convert R, or to convert the resistor R to its impedance, you just simply use R. Okay? To convert L into impedance, you make it LS. Well, S is the S variable in the Laplace transform. Okay? While C, the capacitance, okay, is to be converted into 1 over CS. Okay, as the impedance. Okay? So yun. I hope you are still there and I hope you are getting this. Okay? So, ayan. Now, so parang ganito, no? Bigyan ko kayo ng example. So, let's say for example, you have a circuit like you have a resistor here, you have a capacitor here, and then you have an inductor here. Okay? Let's have, say for example, this is V of t. Okay, this is 2 ohms, this is 4 farad, and this is 3 henries. Okay? So, of course, there is a current flowing through here. Let's call it IT. Okay, let's call it I of t. Now, this is the equivalent circuit. Okay? This is the equivalent circuit in S domain. Sorry. This is the equivalent circuit in S domain. Okay? So, this is V of t becomes V of S. Okay? Or just simply let's just assign it as V na lang. Let's assign it as V. R here, the 2 ohms becomes simply 2 because that's the impedance. Okay? So yung R ohms becomes simply R as an impedance. Okay? This 4 farad capacitor, okay, becomes 1 over 4S. So that's the impedance of your capacitor. Okay? While your inductor, okay, given that L is its inductance, becomes LS as its impedance. So the inductor here has an impedance of 3S. And of course, there is a current here flowing as I of S, but let us just write it as simply I. Okay? And then, for you to be able to get the equation, you proceed with how we have done it here. Okay? You proceed with how we have done it here. Okay? So ayun, that's how we proceed with this problem. Again, you simply just have to convert. Okay, you simply have to convert your circuit into S domain using Laplace transform. Okay? So, a given circuit such as this one is converted into its S domain circuit. Okay? As this. Again, with the following rules, you convert V of t with V of S, but here we just simply write V. Okay? You convert I of t as I of S, but here we just simply write I, so that's okay. Okay? And then convert your components into impedances. So resistor R ohms becomes R in S domain. L henries for inductor becomes LS in S domain. And capacitor C farad becomes 1 over CS in S domain. Then after which, you proceed with KVL, getting the KVL equation. Okay? Now, once you were able to get the KVL equation, halimbawa, you can actually verify those steps here. Okay? In this case, so ito na yung converted. This is the converted already. Okay? So as you can see, we apply the rule as following. Okay? So we start with I1 of S and then multiply it with the impedances connected to I1 or that is passed through by I1. So that is 1 ohm or 1 plus 1 plus 2S. Okay? Which, if you simplify, this becomes 2S plus 2. Okay? And then for I2, okay, again, that has a negative sign for I2 because we are on first loop. Okay? So I2 has a negative sign. And then let's try to see what are common impedances between I2 and I1. So here we see that common impedances are 1 and 2s. So we have it as 1 plus 2s. So here you can see that 2s plus 1 and then negative times I2. Okay? So I hope you are following it here. Okay? You will be able to follow it from this point. Okay? So at this point I will be leaving this to you. Okay? As an exercise. Okay? And you'll be able to figure out how to do this. Okay? Now, another question that you may have is, say for example, this mechanical system. Okay, this mechanical system. You may be able to get an equation here that is similar. Okay, that is similar in method to the electrical networks. Okay, so how? For example, I'll apply it here. First, take note that you have two masses. So mass 1 and mass 2. Okay. That also means that you have that you need two equations because you have two masses. Okay. There should be two objects that can move. So we call that degrees of freedom. So we say that since there are two masses, your system has 2 degrees of freedom. Okay. And by the way, yeah. Okay. By the way, so you have two equations here. You need two equations. Okay. And these are the impedances. Okay. Yung x1 of t is to be converted to x1, all xt's, okay, all x of t's can be converted to x of s, and all f of t to be converted, to f of t is to be converted to f of s. By the way, x is displacement. Okay, and F is force. That's for mechanical system. Again, for mechanical system, your input you push a certain object, so that's a force, and then it produces displacement. It changes its position. Okay? So here, you start with having your xt change to x of s, and then your f of t change to f of t. And then here are the impedances. Here are the impedances. Your m for mass, okay, in kilogram, has an impedance of ms squared. Your f of b, which is the viscous damper, given the units are Newton second per meter, okay, has a impedance of fb times s. Okay, while k, the spring constant, whose unit is Newton per meter, has an impedance of k. Okay, so these are the impedances. Impedances. Okay, and then the x is displacement, f is force. Okay, so for you to be able to come up with an equation for this one, we will follow the certain pattern. Okay, in this case, a mass would correspond to a loop. Okay, so a mass would correspond to a loop. So it means that if you have two masses, parang you have two loops. So therefore, you have to produce two equations if you have two masses. Okay, and then your current here, the current is analogous to displacement. So that means that it is the multiplier to the total impedance. So the displacement is the multiplier to the total impedance. Okay, and the voltage source is the force. So that goes to the right side. The force goes to the right side. So for example, in this case, okay, I would be writing an equation. Okay, I would be writing an equation for equations for this one as this. Okay, I hope you can follow this one. Okay, so we have x1, the displacement of mass 1, okay, there. So the displacement of mass 1, so that's x1, okay. And let us multiply that to all the impedances connected to mass 1. So all impedances, all of those impedances are this. So M1, so M has an impedance of M times S squared. So that's 1 times S squared. So this is S squared, simply S squared. Plus all the viscous damper, 1 plus 1 plus 1 here. So you have 3, okay? So 3 times S as the impedance for viscous damper, okay? Plus the spring constant, 1. There is only one spring constant here, so this is simply 1. And then subtract it to the x2, and then the total impedances that is common to x1 and x2. Okay, so we have here, what is, this is x2 eh. So this x2 is connected to mass 2. So what is the common impedance that are connected both to to M1 and to M2? So in this case, you have this viscous damper, this, and this. Okay? So you have 3 S plus this spring constant. So that is 1. And then equate it to the force. So we have a force here applied to your mass 1. So that would be your F. Okay? So there. And the same thing for x2, for mass 2. Okay? Let's start with x2 here. So x2 represents the displacement of mass 2. So we determine the total impedances for the total impedances connected to mass 2. So that is first itong M2 mismo. So that is 1 times S squared. So that's S squared. Plus the viscous damper, 1, 2, 3, 4. So you have 4 viscous damper, 1 times 4 viscous damper times S. So that's S plus 4S. And then plus, okay, the spring, which is 1. And okay, this takes in positive because this is what is being considered in this mass. Okay, x1 is considered negative. Okay, and we will have to determine the common impedance, the sum of common impedances between x1 and x2, which actually is this one. So this is 3s plus 1. And then equate it to the force acting on f1. The force acting on x2, which in this case we don't see anything, so we will have 0. So this is the set of equations for this system. Okay? So, there. You have questions?
Wala naman.
Feeling ko marami sa inyo wala na dito eh. I think some of you are not listening na already and just trying to see later this in the recording. So I hope that you will be able to follow this, okay? And yeah. So I think we can end up our discussion now on this one, okay? And again, I would just ask you to look at the session of the other class where I was able to discuss this part. Okay, I was able to discuss to them. Actually, most of these parts were discussed there. Okay, most of these parts were discussed in this in the other class. So that is why I would this one were discussed there. So I would like you to watch that in order for you to have a complete discussion of activity 3. Okay? So, yun. I had to go through with the prerequisite courses dahil we're not this is the part where we are not really leveled at. Okay, hindi tayo pantay-pantay dito sa part na to. So that is why I would like us to be on the same page first. Okay? So there, let's end the meeting today. Okay? And again, as a reminder, later tonight is the deadline for the soft deadline for the submission of activities 0 to 3. And then expect within this week that you would be assigned activities 4, 5, and 6, I think. Baka kasama yung 6. Okay? I might include activity 6 also in the next week's assignment. Okay? So, sige, let's dismiss the class na. Thank you for attending and thank you for being patient.
Thank you, sir.
Okay.